Okay, let's do two examples. Here we have a car that's driving off a cliff. It's going at 38 meters per second. So when it jumps, it's going to fall off, and it's going to land over here on this cliff, which is 35 meters above. All right. So now the question is, how fast is it going when it hits the ground? Now we could do this kinematically, but that's going to take a lot of work. So let's do it energetically. So if you remember, non-conservative work causes changes in energy. So here, as I'm jumping, the only thing acting on me is gravity, and gravity is a conservative force. But if it's small enough, and I ignore air friction, there's no non-conservative work. Therefore, the change in energy is zero. So here we go. So 0 equals the change in energy. The change in energy is E final minus E initial. Oops, minus E initial. E initial equals E final. My total initial energy is my kinetic energy initial plus my potential energy initial. That's got to equal my kinetic energy final plus my potential energy final. All right, we've got 1/2 mass of the car, velocity in the original car squared plus mgh initial equals 1/2 mass of the car v final squared plus mass of the car g h final. Oh, look, got mass of the car in all the places. Yay, so it doesn't matter what I'm driving. So I end up with 1/2 v initial squared plus my initial position is 70 g times, we have initial speed 2, we'll plug this in a second, 1/2 v final squared plus g h final. I'm trying to find out what my v final is. Pull this over here, 1/2 v initial squared plus gh initial minus gh final equals 1/2 vf squared times 2 times 2. So I end up with v initial squared plus 2gh initial plus, I'm starting to run out of space, minus 2gh final equals v final squared. Now I'm going to have v initial squared 30, can't see that, 30, well, how fast am I going, 38 squared plus 2 times 10 times my initial height, which is 70. 70 minus 2 times 10 times my final height, which is 35. And that's got to equal v final squared. But let's take the square root of both sides. That gives me a final speed of 61 meters per second. Notice that this is not a direction. All I know is how fast it's going. I have no idea the direction it's going. But I'd totally swap that out to use energy. But now, what happens if my non-conservative work is not 0? Let's launch a firecracker, which you shouldn't do in California because you'll set the state on fire. But in other places, when you light this off and it goes and you end up somewhere over here at 4th of July, everybody's having a great time, and it goes all right. How high did it go? Well, first I need to figure out, so my initial position is 0. I'm sorry, my initial velocity is 0. It starts from rest. My initial position is 0. The mass of the rocket is 0.2 kilograms. Now I'm assuming the change in mass is very, very small. I'm going to call it 0. In most rockets it's not, but this is a nice big heavy rocket, and I'll ignore it. So the height that it finally ends up at is 29 meters. How fast is it going? Oh my goodness, I did my math wrong. This one should be 46 meters per second. Oh. Because we'll see in a second. So now, the engine, the rocket fuel that's inside of here, because I know how much energy it stores chemically, it has 425 joules of energy. And that's how much work is going to be done. It's going to be done by a non-conservative force because it's path dependent. As long as I'm on this path, there's a force that's being done. That force is happening over some delta x, and that's the distance that I'm traveling on. And that's going to be my work. So again, work, non-conservative work causes changes in energy. So I've got 425 joules, and that's got to equal my change in energy, which is my energy final minus energy initial. So what do I got? I've got the energy final, which is the kinetic energy, plus the potential energy final, kinetic energy final, minus the kinetic energy initial, plus the potential energy initial. So what's really, really nice is that the potential, let's see, so this is 425 joules, 425 joules. Kinetic energy final, 1/2 mv squared, plus potential energy final, which is mgh final, minus kinetic energy initial, 1/2 mv initial squared, plus potential energy initial, which is 1 mgh initial. Well, I'm starting at 0, yay, and I'm starting at 0, yay. What do we end up getting? 425 joules. 1/2 times 0.2 kilograms times my V final squared, which is what I don't know, V final squared, plus M, which is 0.2, times G, which is 10, times H final, which is times 29 meters. Solve for V final. 425 minus 2 times 29, which is 2 times 29. 30, 60, 58, minus 58 equals 0.1 times V final squared. And when you do some math, that's where you figure out this one is 61 meters per second. That's what I get for looking at the wrong one.